can be tricky. That's why I wanted you to try it first. Okay. So your h prime of x, remember, bring down our 6, times 4x squared plus 9, we subtract 1, times the derivative of what's inside. Okay. So we end up with 6 times 4x squared plus 9 to the 5th times derivative of 4x squared plus 9. Oh, that's right. Yep, I did. It's 8x. So if we go ahead and multiply those two, our h prime of x is equal to 48x times 4x squared plus 9 to the 5th. Okay. So that part, most of you did pretty good on. Okay. So now you just have to apply the product rule. So that means your second derivative, this is your first and that's your second. Your first times the derivative of your second plus the second times the derivative of the first. Okay. So now that's going to equal 48x times the derivative of 4x squared plus 9 to the 5th. So using the chain rule, we're going to bring that 5 out to the front. 4x squared plus 9. We're going to subtract 1 here, times the derivative of what's inside. Okay, so that just took care of that one. Plus 4x squared plus 9 to the 5th times the derivative of 48x, which is just 48. Oh, that's where I messed up. 4x squared plus 9, even though it ends up being the same thing. There we go. Equals, so we have our 48x times 5 times 4x squared plus 9 to the 4th times derivative of 4x squared plus 9 is just 8x plus 48 times 4x squared plus 9 to the 5th. I just switch those around just because. No specific reason.
Then we just leave it like that?
Nope. Don't leave it like that just yet.
48 in?
Yep. Actually, you can factor a 48 from both of those. Okay, so if you factor a 48 out of there, and actually again, you can factor 4x squared plus 9 to the 4th from both of those. So you can actually factor.
How much credit is this worth up to this point?
48 and I have no idea. Let me move that down a little bit. Factor 48 and 4x squared plus 9 to the 4th. This is to the 5th, this is to the 4th, so we can factor out one of them. So 48, that we factor out of both of those, times 4x squared plus 9 to the 4th, and that just leaves 1 there since we only factored out 4 of them, times x. Remember, you still have your 5 times 8, which is 40. 40, I guess you could say x times, leave that on the outside.
Can we put it as 40x squared?
Hmm?
Can we put it as 40x squared? Multiply 5 and x and 8x?
Yep, so we're just going to combine that x and the 5 and the 8, so that's just 40x squared. I was actually going to skip that, but kind of 40x squared. Once you combine those and that one,
And x plus 3?
plus, remember this is just 4x squared plus 9 to the first, plus 4x squared plus 9.
Then you could combine those two, right?
Yep, so you have 48 times 4x squared plus 9 to the fourth times 44x squared plus 9.
Yikes.
Yep, so it gets really messy really fast.
Yeah, I see.
That's why I've always gone through the habit of the ddx doing that and the ddx doing that, because it kind of keeps me from getting too lost too fast.
Yeah, I left the 5 out. Like, we, the 5.
Yeah, and I've made so many little mistakes finding that one happy medium of, okay, this, if I do this each and every time, I won't mess up as much. So that little ddx kept me from messing up as much. All right, so let's do one more like that one. Oh, is anyone still writing?
Can I ask a question?
Sure.
You got the 40x squared from the x, you factored the x to 5, and then that became 5x, and then 5x times 8x, which made it 40x squared?
Yep. Because remember, all these, everything over here is just multiplied together. So once we factored out the 48 and factored out the 4x squared plus 9 to the fourth, that all came out there. So now it's just everything that's left. All right, so let's do one more. You'll kind of see, hopefully, the pattern. Okay, so if you're given h of x equals 6x squared plus 4 to the sixth, find the second derivative. All right, so for this one, we're going to do the same thing. We're going to find our first derivative. And I'll give you a few minutes to start on that one. right, so we're going to go ahead and get started on this one. Okay, so we go ahead and find our first derivative. We just bring down our 6. 6x squared plus 4. We subtract 1 times the derivative of what's inside. Oops. Okay, so that gives us 6 times 6x squared plus 4 to the 5th. Derivative of 6x squared plus 4 is 12x. Okay, so we get our first derivative is equal to 72x once we combine the 6 and the 12x times 6x squared plus 4 to the 5th. All right, so now we find our second derivative, which here gives us a chain rule. Okay, so our second derivative is just our first, not chain, yep, chain rule, product rule. Let's say that. So we have our first, 72x, times the derivative of our second, 6x squared plus 4 to the 5th, plus the second, 6x squared plus 4 to the 5th, times the derivative of the first. All right, so that gives us 72x times derivative of 6x squared plus 4 to the 5th. Let me make a bracket. So we bring down our 5 times 6x squared plus 4. Then we subtract 1 times the derivative of what's inside. Okay, so that's plus 6x squared plus 4 to the 5th times the derivative of 72x, which is just 72. All right, so that leaves us with 72x times 5, 6x squared plus 4 to the 4th, and the derivative of 6x squared plus 4 is 12x. Plus 6x squared plus 4 to the 5th times 72. Okay, so if you look back at the previous example, notice by the time we got to this point, we could factor out a 48 and a 4x squared plus 9 to the 4th. Here, we can factor out a 72 and a 6x squared plus 4 to the 4th. So it's kind of repeating the steps. If you'll notice that, let me see the first one we did. You notice that you didn't have to do the product rule when you had it 2x minus 3. But when you have x squared, you end up having to do the product rule. So whenever you see an x squared and they're asking for the second derivative, you're going to have to do the product rule on the second one. So you kind of know what to expect. Okay, so here if we factor out 72, and 6x squared plus 4 to the 4th. Okay, so that gives us 72. We factored out, and we can go ahead and draw a quick little line through it. And 6x squared plus 4 to the 4th, factor out 4 here, and that drops that down to 1. 6x squared plus 4 to the 4th. The only thing left here is 5 times x times 12x. which gives us 60x squared. Then you have 6x squared plus 4. To the first power, you don't have to write parentheses or anything. Okay, so that, oh, let me put the other bracket here. So that equals 72. We can gonna combine those. Times 6x squared plus 4 to the 4th times 66x squared plus 4. So you can kind of see the same pattern for both of them. Both of them eventually reach the point where you can factor out that high number in front. And also you can factor out a binomial.
If you go back to the first derivative,
Mhm.
I'm not getting 72x for some reason.
Okay. All right, so for that one, did you, because you remember here, did you bring down the
Yeah, I brought the
6
6
and
down.
subtracted 1? Okay.
Oh, yeah, 6, so I ended up with 6 in parentheses, 6x squared plus 4 to the 5th power
Mm-hmm.
times 6x.
Ah, that was it. Yep.
Bring the 2 down.
Yep. Remember for your
Same
derivative, yep,
thing
got to
I
bring
did.
that down.
Okay.
You did the exact same thing I did.
These,
forgot
it's
about
so
the
many
2.
little steps. It's real easy to miss one. So bring that up. All right. Any other questions on this one? Oh, the derivative of the inside. Bring that 2 down, that became 12x.
Because, okay, hold on, I had 72x multiplied by 5 parentheses 6x squared plus 4 to the 4th
Mhm.
plus 6x squared plus 4 to the 5th times 72.
Yep.
Which is
Yep, you forgot to, remember when you do the chain rule, you have to multiply it by the derivative of what's inside.
And the derivative of what's inside would that be 12x?
Yep, that's your
So-
12x.
I see.
Yep.
And then from that 12x, couldn't that just apply, that would be 5x times 12x, which would get 60x plus, you would still get plus though, right? So it'd be 60x plus 6x squared plus 4x.
Yep, but remember this, 72x times this is just 72x
Right.
times that. So the 72x doesn't go to those two.
Right, so I factored that out afterwards.
Mhm.
And then, that's where, you factor out the 60x squared. Oh, I see, okay.
Yep, so all I did was just multiply
Right,
those
because
three.
you can't factor out the x in both, so.
And you put the x back into the 5?
Yep.
Yep, just multiplying all three of those.
So it would have been 72x times 5, and then factor out the 72 separately, and then, okay, I see. I don't know.
All right, any other questions on that one?
Not really on this question. What's the second derivative find us? I know the first one finds us the tangent line, right?
Yes.
And then what's?
And velocity.
Yep, and velocity. The
Yeah,
second
no,
derivative.
The first derivative is velocity, the second derivative is acceleration.
Yeah.
Thanks, guys.
Mhm. All right.
So the tangent line and velocity is the same thing.
Thank you.
All right, so let's say we have if you remember your derivative of trig functions, remember derivative sine of x is cosine of x. The derivative of cosine of x is negative sine of x. Remember the derivative of tangent x is secant squared x. The derivative of secant x, well, cosecant, I'll do that one first, is negative cosecant cotangent. The derivative of secant, oh, forgot my brackets there. Clean that up a little bit. Okay, so derivative over secant x, remember that's secant x tangent x. And derivative of cotangent x, remember that's negative cosecant squared. Clean that up a little. Of x. Okay. So that's what we went over before, just the derivative of our trig functions. Now let's say if that's something other than x. Let's say if that's 3x squared plus 5 or any function of x at all. Oh. Let's let u equal g of x. Okay, where that's some g of x. Okay, so the derivative of sine of u, well actually let's just use g of x. Just a lot easier. Kind of ignore that u for now. Okay, so sine of g of x. That's just equal to cosine of g of x times g prime of x. So everything up here, once you have a function in there, you're just going to multiply it by the derivative of what's inside. So that means the derivative cosine of g of x is going to equal negative sine g of x times g prime of x. Okay, derivative of tangent of g of x is going to equal secant squared of g of x times g prime of x. And same with cosecant. Oh, g of x. That's going to equal negative cosecant of g of x times cotangent of g of x, all times g prime of x. Okay, same thing with secant. That's going to equal secant of g of x tangent of g of x times g prime of x. And the cotangent, same thing. That's negative cosecant squared of g of x times g prime of x. Alright, so let's do a quick example of this one. Okay, so let's say when f of x equals cosine of 3x squared, find f prime of x. Okay, so with that one, we know that f prime of x is just going to equal the derivative of cosine of 3x squared. Okay, so that's going to equal, derivative of cosine is just negative sine. So you have negative sine of 3x squared times the derivative of what's inside. Okay, so it's pretty much the exact same thing. You're just going to multiply it by what's inside, the derivative of what's inside. So you have negative sine of 3x squared times 6x. Okay, so your f prime of x is just going to equal negative 6x sine of 3x squared. Okay, so if you already memorized the trig derivatives, you don't really have to memorize anything else. Just multiply it by derivative of what's inside.
So it's the sine of 3x squared is its own parentheses, so you can't multiply the 6x into the 3x squared.
No, you can't.
So that's like its own parentheses, right?
Yep, exactly. That's like having 2 times sine of x. You can't make that sine of 2x. So you wouldn't be able to do that. All right. So any questions on this one? All right. And I wanted to do one more example, but I don't think we have time. Actually, yeah, we'll probably do it really quick, just in case you run across it. Should take like 2 minutes. Composition of 3 functions. Okay. So if you have some k of x equals h of f of g of x, and k prime of x is going to equal h prime of f of g of x times f prime of g of x times g prime of x. And you use those mostly with trig function derivatives that are higher than just to the first power. Okay. So let's say, real quick example here. If you want to find the derivative of k of x equals cosine fourth of 7x squared plus 1. And that's going to shut off.